identify the complex relationships between pixels and water data. On the other hand, deep learning solutions are more suitable for unstructured data like images, videos, and text. Tasks for deep learning include image classification and natural language processing, where there is a need to identify the complex relationships between pixels and words. For example, a deep learning solution can analyze social media mentions or product feedback to determine user sentiment. Both types of machine learning use statistical algorithms, but only deep learning uses neural networks to simulate human intelligence. As we've seen, deep learning models self-learn patterns, so they don't require as much work on selecting and extracting features. However, their infrastructure costs are significantly higher. Finally, let's finish this lesson by talking more about generative AI. Generative AI is accomplished by using deep learning models that are pre-trained on extremely large datasets containing strings of text, or in AI terms, sequences. They use transformer neural networks, which change an input sequence, in GenAI known as prompt, into an output sequence, which is the response to your prompt. Neural networks process the elements of a sequence sequentially, one word at a time. Transformers process the sequence in parallel, which speeds up the training and allows much bigger datasets to be used. Large language models contain many billions of features, which captures a wide range of human knowledge. With all this training, large models are very flexible in the tasks they can perform. They outperform other ML approaches to natural language processing. They excel at understanding human language, so they can read long articles and summarize them. They are also great at generating text that's similar to the way a human would. As a result, they are good at language translation and even writing original stories, letters, articles, and poetry. They even know computer programming languages and can write code for software developers. Here I asked Amazon Bedrock to explain large language models. If you want to try Amazon Bedrock for yourself, for free, you can build your own AI app at PotterRock.aws. Alright, let's get started with task statement 1.2 in the next lesson. Now let's review the second task statement from domain 1, which is to identify practical use cases for AI. This task statement is split into 5 lessons. Let's start by reviewing some use cases and scenarios for which AI and ML should be considered. Unlike humans, AI technology can work all day, every day, without decreasing rates of performance. You can use AI to focus on repetitive, tedious tasks that employees struggle with or find boring. AI can decrease employees' workloads while streamlining all business-related operations. AI technology can use ML and deep learning networks to solve complex problems with human-like intelligence. AI is a great choice for solving complex problems that involve analyzing vast amounts of data at high velocity that humans could not be able to do. Because AI is very good at recognizing patterns, it is great at detecting deviations in patterns and uncovering fraud. It helps reduce waste by forecasting the demand for products or resources. Companies can make better choices, become more efficient, and better address their customer needs. We have seen that there are a lot of useful applications for artificial intelligence. However, it isn't the solution to every problem. Let's go over some use cases where AI is not the best option. Training AI with machine learning consumes vast resources. Processing power can be costly, and models might need to be retrained frequently. Before embarking on a costly AI project, you should be certain that the benefits to the business will outweigh the costs of the AI solution. For example, have targets for the dollar amounts of fraud and waste reduction, and then estimate the costs to build a model to meet those targets. If the costs exceed the savings, then you probably shouldn't proceed. AI models can be used to make decisions that impact customers. For example, when someone applies for a loan, it's important to make sure that models are trustworthy and understandable. However, complex neural networks model the human brain. You cannot fully understand how and why the inner mechanics impact the prediction, which is known as models interpretability. Complex models generally present a trade off of compatibility compared with interpretability. If these are business or compliance requirements for complete transparency, then less complex models will need to be used, which will usually result in lower performance. An alternative is to use a rule based system that doesn't require AI. For example, a rule might be that people with a credit score about 750 should be automatically approved for a loan of $10,000 or less. If a software application always produces the same output for the same input, it is said to be deterministic. A rule based application is deterministic unless someone changes the rules. Machine learning models, however, are probabilistic. That is, they determine the likelihood of something. They learn and adapt over time and incorporate randomness into their approach. As a result, identical sets of input values will result in a variety of results that aren't consistent. If determinism is necessary, then a rule-based system is a better option. I'm going to pause this lesson here, and in the next lesson, we will continue talking about task statement 1.2.